Okay, I've got this document which I posted online several days ago. Um, there are how many groups here? About 10 groups of problems. First group is just the stuff you were asked to do on the major quiz. I'm not going to talk too much about it today because there are other things we need to talk about. But you need to be able to construct any of the toolkit functions. And you need to be able to do that in a window where I specify position of the red dot, position of the lower left corner or whatever. So you need to be able to do that sort of thing. But it's exactly what you had to do on the original test. Group 2 is just about inverse functions. What do you need to know about inverse functions? Well, I'll write a few things down. This is going to be abbreviated. I don't want to take a lot of time with this right now. Inverse functions. You swap X and Y. You graph and or solve for Y. You check it. Check whether F inverse of X, F of F inverse of X equals F inverse of F of X equals X. And you got to be able to do a little algebra to solve for Y when you switch the coordinates. That should be very familiar to you. So this is just kind of a summary of what I said, a little more in words there and what we've done in more detail in class. Okay. Then you have rate of change problems. Should be familiar with my abbreviation ROC for rate of change. You could see the rate of change as a fundamental, the slope of a fundamental triangle. Between graph points. Rate of change on an interval, take the graph point at each end of the interval. And do the point. Again, those questions were covered prior to the major quiz. So that's something you should know how to do. So I'm not going to say much about it. Composite functions. There are no problems on this set that ask you to do the composite of two given functions, but could ask you to do the composite of two given functions. That could occur. Or problems like the ones we have here. Where you break the given composite function into two functions, okay? Again, that occurred on the major quiz, so at this point, pretty much on the major quiz. Now, get down to group 5. There's a problem. Where there's applied information that gives you 2 points on the graph. In the first problem, it says in month 7, your monthly profit's $30,000. In month 9, it's $40,000. Represent is 2 points on the graph. And sketch a graph of a straight line through the 2 points. Okay. You'll be able to do that. Just for that example, you got month 7 and month 9, and you got 30,000. You got 40,000. So there's 2 points. Make sense? Now, I'm not labeling all the units and everything, and you need to. So it's not a complete graph, just a reference sketch to give you the idea. And then, of course, you go ahead and draw a line through the points. And then completely labeled fundamental triangle. I'll just draw a triangle in blue and put a few dots here where things need to be labeled. And label it according to conventions. They'll tell me over here on another page that the slope is 5/8. Slope is 5/8. It goes there in a box. We'll even draw that little box. And the rise goes here and the run goes here. You need to show the calculation, all the details as I've stressed them. Okay. If you don't remember exactly what it is, review it. You should probably have it in your notes, but if not, find it in the videos. Okay. And then explain. Why is the slope and the average rate of change the same, et cetera, et cetera. And then, of course, you got average rate of change. Okay, and y divided by change in x. You expand that to y2 minus y1 over x2 minus x1. But maybe you're not even given y2 and y1. Maybe you're already given the change and you get 2x values. You got to be able to use that. It's a basic tool, and it's actually a tool that applies in a lot of ways, potentially applies throughout life. You can read the more details in the problems. Find the equation of a straight line through 2 given points, sketch, label, etc. Okay, that's group 6, and that's so straightforward that I'm not going to even talk about it. Okay, it's what we've been doing lately. But then use transformations of toolkit squaring function. And then a note could be reciprocal or the exponential function. Be able to construct toolkit shape. Okay. And then transform. That's basically something again from prior to the major quiz, okay? But we're getting right into it, and we're going to talk more about that shortly because that's kind of the next assignment. Group 8 is what we're going to be talking about here in just a few minutes. And there'll be a problem from group 8 on the test. If you know how to do it, do it. If you don't, we won't count it, but it's going to be on the next test too. So you're going to have to do it. So you might as well learn to do it so you can get the points on this test and on the next test. Okay, fair enough? Okay. Then we do the thing that we did last time for the power functions. Okay, doing the arithmetic. So group 9 is what we just did. Previously, and that will be included. Okay. Group 10, piecewise functions. Now, in this case, I tell you the three functions are exponential, squaring, and reciprocal functions, okay? So I would draw a window. And I'd draw squaring function in that window. I draw an exponential function in that window, and I draw a reciprocal function in that window. Those aren't drawn very well, but there they are, okay? And maybe give each one a different color, but no, you know what they are. Okay, now, on three intervals, so we'll just put one interval here, another interval here, okay? All I have to do there is say, okay, it's equal to the reciprocal function on this interval. It's equal to the exponential function on this interval. And it's equal to the squaring function on this interval. That makes sense? So all the rest of the white lines aren't important. Right here is your graph, and maybe you include this point, and if you include this one, you don't include this one. Maybe that one's going to be included, this one isn't, this one is, and this one is. Okay, so you put your dots on there, then you write down the definition of the function. Now, the way that's often written, first, it's reciprocal function. Second, it's exponential function. Third, it's squaring function. And if this is the interval here from negative 12 to 12, and that would be x equals 12 and x equals negative 12. Then maybe this is from negative 12 to negative 4. This one from negative 4 to 4. And this one from 4 to 12. So if this is negative 12 and this is 12, then if you split it equally into three equal intervals, just for an example, intervals go from negative 12 to negative 4, negative 4 to 4, 4 to 12. You get those from negative 12 to 12, that's 24 units. Divide that by 3, it's 8. So you go 8 units from here, 8 units from there, 8 units there, and you get 12, 4, negative 4, 4, and 12. Okay. Now there might be something else, but that's how you would denote this function. Okay. And that should be clear because you've had problems in your homework on linear functions, on piecewise functions, and most recently on piecewise linear function. Okay, and that gets us down to group 10, wasn't that group 10? Yeah. Okay, then there's group 11, and there's a series of problems there I'm not going to talk about, except in the context of something that we're doing to move ahead in the course, okay? Because those problems are optional, meaning that if you do them and they help, we'll count them. And if they don't help, we won't count them. Okay, that's on a problem by problem basis. This problem helps you, but this one doesn't. Well, we'll count the one that helps you and we'll ignore the one that doesn't. Okay. So you might well run into problems in that last group. But if you're not fully prepared to do everything in the other groups, then I don't recommend you worry too much about those problems. You might glance over them just to get your brain working on them. And you might have a good time with it. Okay. Can't tell you yet how many problems there'll be on the test. I'm going to make every effort to get the problems into the testing center tomorrow afternoon. You're going to get a test. So you can take it this weekend if you want. But I've had a couple of time-consuming things just, you know. That were kind of unanticipated. So I'm in a little bit of a time squeeze. I still think I can get it done, but I often do. Okay, if it's not there before the weekend, it'll be there early next week, Monday afternoon probably. And it'll be due a week from this coming Tuesday, which is the last day before drop. Okay, and incidentally, mentioning the drop date, if you happen to be failing after this test, I will probably I'm not sure what. Let me know. Say, hey, if I'm failing after this test, if I'm failing after next Tuesday, please drop me. If I drop you, as opposed to you dropping yourself, then we've got like a week to figure out, okay, what can we do? Can we get you on track so you have a good way to pass the course, okay? Gives it a little time to consider the situation. You understand what I'm talking about? That's not going to apply to most of it because most of it, I think you're doing okay. But there's some people I'm a little concerned about. So you can email me asking me to do that if you happen not to be passing as of next Wednesday. And then we can meet, talk about it, and figure out just why. Is there something we can do? Is there something we can do to get you on track? Okay. But you got to email me. Otherwise, you'll be stuck. If you're failing and end up failing, you're going to get that F as opposed to a W. Yeah, of course, you can drop yourself too if you decide that's necessary. And if you're concerned about that, email me. Tell you what I think your status is. Your first test is a pretty good indication. Okay. Going to move on and talk about quadratic functions. You already know pretty much everything. Let's pull it together. And I'm just going to do an example. I'll start with an easy example. Y equals 2 times the quantity x minus 3 squared minus 6. If we want to graph this, this is a f of x minus h plus k, where f of x equals x squared. A equals 2, which is a vertical stretch. H equals 3, your horizontal shift. K equals negative 6. Vertical shift. So we start with your toolkit quadratic function. And I'm drawing this graph small and quickly because there you have it. Labeled, and then you label your construction lines, you know, this is y equals 2, et cetera, et cetera. Okay, you know, A is 2. That's your vertical stretch. So you sketch it again. The y goes from 0 to 8 because your vertical stretch multiplies your y coordinates. And without drawing all the lines and stuff, your red dot is still where it is because the y coordinate of the red dot is 0. And if you multiply that by 2, you still get 0. Okay, so y equals 0 stays y equals 0. If you're multiplying by 2, y equals 4 becomes y equals 8. And we get this graph, and you can draw in the construction lines and label them and everything. Also, again, x equals negative 2 here, x equals 2 here. X equals 0, of course, at the vertex. Then what? Well, that's the hard part. The rest of it is just take this graph here and redraw it. And now, this point, which was 0, 0, your red dot was 0, 0. It's now horizontally shifted 3 units and vertically shifted negative 6 units, so that your red dot is at 3, negative 6. Take this, move it over 3 units. X is going to become 3. Move it down 6 units. Y is going to become negative 6. And right there's your graph. Not very well drawn. Okay. Now let's estimate. Now you got to know that if this is 3, -6, the dimensions of this thing haven't changed, so that this corner is 2 units to the left of the vertex. This corner is 2 units to the right. So this is x equals 1. And this is x equals 5. Still 4 units wide. And y has gone down to -6 here. And what's y here? Well, this thing is 8 units high, so this has to be y equals 2. So we take the 4x4 rectangle, vertically stretch it to get an 8x4 rectangle, and then shift the red dot at the origin to the point 3, -6, and we have an approximate graph. Okay, what's the y coordinate here? Well, if it's 8 units from here to here, then it would be 4 units up to about here. So that might be pretty close to y equals 6. Let's pretend, or not, y equals 0. That would be your y-axis, incidentally, right? Hey, I'm sorry, your x-axis. Let's estimate and let's give this function a name. We're going to call it g of x. Matter of fact, I'm going to go up here and call it g of x at the beginning. Solution of g of x equals 0. Well, right here are the points for y equals g of x equals 0. G of x is 0 here, g of x is 0 here. Draw a vertical line down here, draw a vertical line down here. And we can estimate the x coordinate here and here. If this is 1 and this is 3, then 2 would be about here, so that's about 1/2. And over here, maybe it's about 4.3 from the graph. Now we know since the graph is symmetric, if this is half a unit to the right of the lower left corner, this is half a unit to the left of the lower right corner, okay? So if this is 1/2, this should actually be 4.5, but I'm fudging my bets because I don't think either one of them is that accurate. Maybe one of them will be more accurate than the other. Now that's a process you should be really familiar with, okay? Now we could solve. G of x is equal to 2 times the quantity x minus 3 squared minus 6. Well, I don't have room to solve it there, but I have room here. 2 times x minus 3 squared minus 6 equals 0. I add 6 to both sides. I'm going to skip these steps because they should be familiar to you. I add 6 to both sides, I get this. If I divide both sides by 3, up here, I'll say add 6 to get this. Divide by 2 to get x minus 3 squared equals 3. And then square root. So x minus 3 equals plus or minus the square root of 3. So that x equals 3 plus or minus the square root of 3. And the plus gives me 3 plus 1.732. Or 4.732 or 1.28. Now, when I estimated x equals 1/2 here, that was ignorant because this is x equals 1. I was estimating that distance is 1/2. So if I estimate 3/2, that's a little better, but still it's not great. My 4.3 should have been closer to 4.8. My 3/2 should have been closer to, well, that's like 1.5, should be closer to about 1.28 or 1.25. Point is, from that graph, I can't expect to get a really good estimate. The shape of the thing isn't really a good parabola. I didn't do the construction. I didn't make it big enough. I got kind of a bad looking parabola, a little too squeezed in at the top. But I got estimates that are at least reminiscent of the solutions. Okay, so you got to be able to do that. Make sense? And that sort of thing could be on the test. Now there's other techniques. How about this one? Well, not minus 14. 2x squared minus 12x plus 12. Let me make sure that's right. It'd be 18 minus 6, yeah. Okay, I think that's right. How are we going to graph that? Well, somebody could write down the quadratic formula right now. Okay, well, we got to use a quadratic formula. Is that familiar? Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Yeah, well, depends on how long it's been since you've seen it. Yeah, what the quadratic formula is good for is if you have any quadratic function equal to 0, the quadratic formula tells you what the solutions are. Now we can draw a graph and estimate solutions. If the function is in this form, and this can be put into this form, then we can easily solve it without using the quadratic formula or anything, except just what we know about basic algebra. Okay, now mystery. You have A, you have B here and here, and you have A here again, and you have C. What's A? A is the number in front of x squared. B is the number in front of x. And C is the number that doesn't have an x. Okay? So that's really easy. You just plug the numbers in and then get your arithmetic right. Okay? So there's how you identify A, B, and C. Open Math will tell you more. So x is negative of negative 12 plus or minus the square root of negative 12 squared minus 4 times 2 times 12. All divided by 2 times 2. So you see that B is negative 12, B is negative 12. This A is 2, this A is 2. We have the negative 4, that's always there. And C is 12. They're all our numbers. If I do the arithmetic, this comes out 12 plus or minus the square root of what? Well, 12 squared is 144. 4 times 2 is 8. 8 times 12 is 96. So all this stuff under here comes out 96. And that's over 4. Now I've got a problem there. This isn't agreeing with my solution over here because I might have done something wrong. But I've got 3 plus or minus the square root of 4AC. That's right. It is like 96, 144. 144 minus 96. I wrote the 96 down. 144 minus 96 is 48. And there it is. That comes out. Now, I've done a couple of things that need to learn to do. But they're pretty straightforward. So the quadratic formula shouldn't scare anybody. It's going to tell us where the zeros are. Make sense? Well, now we can start to draw the graph. Negative 3 minus the square root of 3 is like 1.3. It's 1.28. So we can say, okay, x equals 1.28 here, and it equals 4.732 out here. Y is 0 at those points, so those are x-intercepts. Okay? So from the quadratic formula, if the graph goes through the x-axis, quadratical formula will tell you where, why. Just set the function equal to 0, and you're going to get the points 1.280, 4.7320. Okay, now that's more decimal places than you're going to really need to do a graph. So you can be more reasonable with the number of decimal places. think that should be 1.228, but okay, I'm not going to mess with it. Okay, well. Where's the axis of symmetry? You know this is going to be a parabola. Okay. Because this is just what you get when you expand this. Multiply x minus 3 by x minus 3, multiply it by 2, subtract 6, you get this. So this is the same thing as this is, you just do a little arithmetic with the distributive law here. Well, the rest of it is, where's your axis of symmetry? Well, it turns out your zeros are between 3 plus the square root of 3 and 3 minus the square root of 3, right? What's halfway between 3 plus the square root of 3 and 3 minus the square root of 3? Can you show with your fingers? What's halfway between my nose and the distance from my nose to my left here and my nose minus my distance to the right here? Okay, if this is 4 inches, nose plus 4 inches, nose minus 4 inches. What's halfway between nose plus 4 inches and nose minus 4 inches? Nose. Okay. Halfway between something plus a quantity and that same thing minus a quantity is that thing. Fair enough? So I know the axis of symmetry is 3. Because the axis of symmetry has to be halfway between the zeros because things are symmetric about that axis. The zeros have to be same distance on either side of the axis of symmetry. Okay. What else do we need to know to sketch a graph of this thing? Well, if we knew the vertex and the zeros, we could sketch a parabola, couldn't we? It's kind of like we did here. Now, yeah, we actually know where the vertex is going to be, assuming this is the same as this. It's going to be at -6, right? Y equals -6. But let's pretend we don't know that. All we know is we have this function. We don't know about this form. How are we going to find the vertex? So x equals 3 at the vertex. Thus, y equals g of 3 at the vertex. We're going to plug 3 in here and see what x is. And that equals, well, x squared is 9. 2 times that is 18. 12x is 12 times 3, which is 36, but it's minus 36. 18 minus 36 is -18. And we add 12 to that and we get -6. So right there is the calculation of the vertex. Well, we can put the vertex wherever or we can put y equals -6 wherever we want to. So I'm going to put it here. So here's my vertex. And if you want, that corresponds to the red dot. There's my vertex. There's one other point I can get, which is the y-intercept. Now, I've kind of tried to drill it into, look, x-intercept occurs when y equals 0, the y-intercept occurs when x equals 0, okay? I mean, here's the y-axis, x equals 0 everywhere on the y-axis. If we plug 0 in for x, what do we get? This is 0, this is 0, so we're going to get 12. So let's see, if that's -6, 12 would be up about here. So I guess I'm going to have to extend my y-axis a little bit. So I'm going to say y equals 12 about here. Okay, does it make sense that a parabola would go through all four of these points? I think it makes pretty good sense. We bring it on down here, and then we go around here, and go on back up. Looks like a pretty good parabola. That makes sense. Okay, so what's the procedure that we used here? Let's try to make this as coherent as we can. About that. Okay, I've got all this board to use. Not totally ingrained to you that the x-intercept occurs for y equals 0. It's probably because you haven't been writing this out every time. And so find the x-intercept for y equals 0. Quadratic formula is easy to use. Okay. So if I put numbers in here, you can always plug them into the quadratic formula and see where the graph crosses the x-axis. Now, if you happen to get a negative under the square root here, it means the graph doesn't cross the x-axis. The only way it can cross the x-axis is to be a solution of the quadratic formula, and that solution has to be a real number. Got a negative under the square root, you got an imaginary number there. Okay? Which makes your solution complex there, a complex number. And we're not worried about that right now. We'll worry about it a little bit in about a week or two, but there it is. If this number under the square root comes out positive, you're going to get two solutions. If it happens to be 0, you're only going to get one solution, because when you add 0, you get the same thing as you get if you subtract 0. So anyhow, there it is. Now, another bonus. Here's where the axis of symmetry is. Why is this the axis of symmetry? It's right here in the quadratic formula. X equals negative b over, oh, I didn't write the a on that. X equals negative b over 2a. Okay. And why is that the axis of symmetry? Because it's halfway between what you get if you do negative b plus the square root and negative b minus the square root. There's the nose, there's the right ear and the left ear. The nose is halfway between. If you're a totally symmetric human being. And there aren't many of those. Everybody's a little off symmetry one place or another. Okay, so that's a whole lot of information about the graph. Tells you where the axis of symmetry is, tells you where the zeros are, and this is the axis of symmetry, even if you get a negative under the radical here. You're always going to get the axis of symmetry. All right. You got a further bonus. You plug in negative b over 2a and you get the y coordinate of the vertex, so you know where the vertex is. Okay. So all this comes under what you get out of the quadratic formula. And after you've done it a couple of times, you'll be able to do it. It's not difficult, it only requires practice. Well, what else can you do? Well, find the y-intercept. That's easy. Plug in 0. This is 0, this is 0, so y is c, whatever that number happens to be. So what do you have at this point? You have a vertex. First of all, you have the axis of symmetry. Vertex. Make that our red dot. Okay, where's your y-axis? Well, that depends on where the axis of symmetry is. And it's over here somewhere, so we'll just put the y-axis could be to the left of the vertex or to the right. The vertex could be in any quadrant, right? Depending what your numbers are. But we'll just put a y-axis over here, let's say. And that's going to be at the point that's 0C. We don't know where the x-axis is, but we know this much. Always. And then maybe we know where the x-axis is, we can figure it out. But I'm not gonna draw an x-axis because at this point, I don't know how the quadratic formula actually worked out, whether I actually got solutions or not. If I didn't get solutions, that means the graph doesn't go through the x-axis. It means the x-axis is down below the vertex. At least in this case. So how am I going to draw my parabola? Well, here's a point, right? Here's an axis of symmetry. How do I get another point? Take this point, put one an equal distance over here, right? So got this for free. Okay. And it doesn't matter whether you have x-intercepts or not. Okay. If the graph is opening upward above the x-axis, you don't have x-intercepts. But you can still draw the parabola because you don't need x-intercepts. To help, if you have them, use them like we did over here. Okay. But if you don't have them, if this graph had been a few units higher, you wouldn't have had them. You'd still have this point and then the symmetric point over here. So now we sketch the graph in a parabolic shape. If I get myself down to the vertex, handle the block, I mean, I didn't go quite far enough. You get the idea, you can sketch a graph. Matter of fact, you can sketch a rectangle here and start subdividing it and sketch a very accurate graph. If you have 2 points symmetric about the axis of symmetry and the vertex, you can draw a square, subdivide it just like we did on the first day of class, and sketch yourself a beautiful parabola. Actually, I think we did the exponential function first. The second day we did the parabola, and everybody was doing that right. Okay. So that's a pretty good sketch of what you need to be able to graph an arbitrary quadratic function. Now, what transformations would we use to get here? Well, the vertex has an x coordinate, and that's your horizontal shift, right? It has a y coordinate, and that's your vertical shift. And then this box has certain dimensions, and that part involves a little bit more than I'm not going to talk about right now, but you know where the vertex is, and you know there's been a vertical shift, whatever the value of A is, unless A is 1, there's been a vertical stretch, and maybe a reflection, maybe the graph is upside down. Okay, this form here is the general form of a quadratic function. This is the vertex form. From the vertex form, you can see exactly what the transformations were and where the vertex is. The vertex is at HK, which is 3, -6. Your horizontal shift here would be 3. That's going to give you the x coordinate of the axis of symmetry. And the vertical shift is -6. They're shifting from y equals 0 down to y equals -6. So your vertex is at 3, -6. Okay, very easy to see. Not so easy to see here, but I could write this in vertex form because I see what the axis of symmetry is and I figured out what the y coordinate is. So I know my horizontal shift is 3, my vertical shift is -6. And the vertical stretch factor, whatever's in front of x squared, is same in both cases. If it's 2 here, it's 2 here. Make sense? So you can connect these forms, and if you do the analysis that I outlined over here, you know where the vertex is, so you know what the horizontal and vertical shifts are. Okay? So whatever the horizontal and vertical shifts are, they're going to replace the 3 here and the -6 here. And then you know the vertical stretch factor. That's just A. If you're given all these numbers, A, B, and C, you got it. So you would conclude from what we have here or actually what we have here from this function, that this is x minus 3 quantity squared because the axis of symmetry is that x equals 3. And then -6 because the y coordinate of the vertex is -6. And we inherit the 2. That's our vertical stretch. Okay. What was that beep? Was that my computer? Stop it. Okay. It won't do that again. Okay, simple or straightforward application actually. You got a car rolling down an incline, distance from the top is this. For t, that script thing is feet. Okay, you see the F and the T. Everything else in between there is whatever it is. We can graph this. If we apply the analysis, the axis of symmetry is t equals -1. It's negative b over 2a. B is 4, a is 2. Double to 2, divided into 4, you get 1. But it's negative. Okay? Y-intercept is at 6, 0. At 0, 6. When t equals -1, we plug -1 in and we get 2 and -4 and 6, which is 4. This is our d-axis, this is our t-axis. D equals 4 here. There's this point. We can use symmetry to show there's another point here, a reflection of this one across the vertex. So we think our parabola might look something like this. Okay. What is D when t equals 1? Well, we can go to the graph and estimate it. And that's our point here. And if this is 6, then there'd be 12 here. This looks like D equals about 9.5. That's estimated. What can we do? When t equals 1, we can plug that in here. If t equals 1, we actually get d equals 12. So my estimate wasn't much good. Okay. I guess my probably didn't get steep enough here. The point is that this gives you a graph that you could use to estimate how far the thing is, or when it's at this point or another point. And this does represent the motion of the car down the ramp. However, the domain of the function is only from 0 on. The graph has a part over here that helps you graph it, but it doesn't correspond to reality because the car didn't start rolling until t was 0. Okay? So it's a perfectly good parabola on both sides. The actual motion doesn't start until t equals 0. You're going to see problems that involve graphs of quadratic functions or quadratic functions themselves and questions about it, like what's the distance, or what's one quantity or another. Anyhow, we're out of time, so we have places to go, and we'll stop there. Please feel free to email me questions about the test problem, anything you're not certain of. We'll talk some more about that on Tuesday.